Welcome students to MOOC's series of lectures on advanced probability theory. This is lecture number 23. If you remember, we are working on ordered statistics and we have derived that if x 1, x 2, x n are IIDs following parent distribution f x, then if R x is equal to factorial n upon factorial r minus 1 into n minus r factorial f x to the power r minus 1 minus f x to the power n minus r multiplied by f x. Before we proceed any further, let me solve some examples. Suppose x 1, x 2, x n are IID uniform 0 1, what is the expectation of A x 1 and B x n? Now, we need to first compute the PDF of x 1. So, we go from the basics 0 1. So, we are considering a point x and we are saying that x 1 is at x. What is the PDF? So, before x, therefore, there are 0 observations, then 1 observation is at x and remaining n minus 1 observations are in this region. Therefore, if 1 x is equal to n c 1, choosing this one element f x multiplied by 1 minus f x whole to the power n minus 1 is equal to n f x is equal to 1 because it is uniform 0 1 and 1 minus f x is equal to 1 minus x whole to the power n minus 1 is equal to n into 1 minus x whole to the power n minus 1. Therefore, expected value of x 1 is equal to integration 0 to 1 x into n into 1 minus x whole to the power n minus 1 dx is equal to n into integration 0 to 1 x to the power 2 minus 1 into 1 minus x whole to the power n minus 1 dx. Now, this is a beta integral and that is going to give us beta 2 comma n is equal to gamma 2 gamma n upon gamma n plus 2. Therefore, expected value of x 1 is equal to n into gamma 2 is equal to factorial 1, gamma n is equal to factorial n minus 1, gamma n plus 2 is equal to n plus 1 factorial is equal to n factorial upon n plus 1 factorial is equal to 1 upon n plus 1. Let us now compute expected value of x n, the nth order statistic. So, PDF of x n is equal to f n x, we compute as follows. Suppose it is 0, it is 1, this is x, and the nth observation is here. So, that will give us f x. All other remaining n minus 1 will be in this region. So, that will give us f x to the power n minus 1, and there should be 0 observations here. Therefore, f n x is equal to n c n minus 1 f x to the power n minus 1 into f x is equal to n x to the power n minus 1 into 1 is equal to n x to the power n minus 1. Therefore, expected value of x n is equal to integration 0 to 1 x n x to the power n minus 1 dx is equal to n into 0 to 1 x to the power n dx is equal to n into x to the power n plus 1 upon n plus 1 0 to 1, which is equal to n upon n plus 1. Therefore, expectation of x 1 is equal to 1 upon n plus 1, expectation of x n is equal to n upon n plus 1. Hence, the expected value of the range. What is range? Range is equal to maximum minus minimum is equal to x n minus x 1. Therefore, expected value of range is equal to expected value of x n minus expected value of x 1 by linearity of expectation is equal to n upon n plus 1 minus 1 upon n plus 1 is equal to n minus 1 upon n plus 1. This same result may be derived by considering the joint PDF of x 1 and x n and computing the expectation of x n minus x 1. But to do that, we need the joint PDF of x 1 and x n. We follow the same trick as we did for computing FR. So, the problem is x1, x2, xn follow a PDF fx. We need joint PDF of x r and x s, where 1 less than equal to r, strictly less than s less than equal to n. For notational convenience, let x r be called x and x s be called y. We are looking at f x y at x y. So, as before, suppose this is the real line, this is the point x, this is the point y. Therefore, the rth order statistic is going to take this value, which we know will give f x. The sth order statistic is going to take the value y, and that we get from f y. Now, r minus 1 many values are here. For them, we shall get f x to the power r minus 1, s minus r minus 1 values are there. For them, we will get f y minus f x, because they are lying between x and y, and for remaining n minus s, we shall get 1 minus f y to the power n minus s. Once we understand that, we can compute the PDF. Therefore, if r s at x y, this is the joint PDF of x r and x s, is equal to n c r minus 1 f x to the power r minus 1, then out of n minus r plus 1 we choose 1 and we give f x. Out of remaining n minus r, we choose s minus r minus 1. We assign the probability f y minus f x to the power s minus r minus 1. Then out of n minus s plus 1, we choose 1, give the value f y, and the remaining n minus s, they get 1 minus f y, therefore, whole to the power n minus s. Apparently very complicated, we try to simplify it, is equal to factorial n upon factorial r minus 1 into factorial n minus r plus 1 f x to the power r minus 1 multiplied by n minus r plus 1 factorial upon 1 factorial into n minus r factorial, and we give the value f x, then n minus r factorial upon s minus r minus 1 factorial into n minus s plus 1 factorial multiplied by f y minus f x, f y minus f x to the power s minus r minus 1 multiplied by n minus s plus 1 factorial upon 1 factorial into n minus s factorial multiplied by f y multiplied by 1 minus f y whole to the power n minus s is equal to, if we look at this gets cancelled with this, n minus r factorial gets cancelled with n minus r factorial, s minus r, n minus s plus 1 factorial gets cancelled with n minus s plus 1 factorial. Therefore, we get n factorial upon r minus 1 factorial into s minus r minus 1 factorial into n minus s factorial, and this multiplied by f x to the power r minus 1, f y minus f x to the power s minus r minus 1, 1 minus f y to the power n minus s into f x into f y. So, that is the joint PDF of x r and x s at x y. We are not going to give the mathematical proof. We have already understood the approach. Therefore, from there we are going to solve the problem. The problem is to compute expected value of x n minus x 1, that is expected value of range. Therefore, what we do, joint PDF of x 1 and x n at the point x y. Therefore, we write in a very similar way is equal to, this is x, x 1 is coming here, this is y, x n is coming here. So, there is nothing on this side, there is nothing on this side, and remaining n minus 2 observations are here. Therefore, the joint PDF we can easily write it as n c 1 f x out of the n minus 1, n minus 1 c 1 that we put at f y multiplied by f y minus f x whole to the power n minus 2 is equal to n into n minus 1 into f x into f y into f y minus f x whole to the power n minus 2. Since the parent distribution is uniform 0 1, therefore, f x is equal to 1 is equal to f y and f x is equal to x. Hence, putting the value here n into n minus 1 into 1 into 1 into y minus x whole to the power n minus 2 is equal to n into n minus 1 into y minus x whole to the power n minus 2. So, that is the joint PDF of x 1 and x n. Therefore, expected value of x n minus x 1 is equal to, now we have to use double integration n into n minus 1 into y minus x whole to the power n minus 2 multiplied by y minus x. So, this is the function for which we are trying to find out the expectation into dy dx. Now, we have to put the range. Y cannot be less than x, therefore, range of y is equal to x to 1 and x can be anything between 0 to 1 is equal to integration 0 to 1 integration x to 1 n into n minus 1 into y minus x whole to the power n minus 1 dy dx is equal to 0 to 1 n into n minus 1. Now, we are integrating y minus x whole to the power n minus 1 with respect to y. Therefore, we are getting y minus x whole to the power n upon n x to 1 dx is equal to integration 0 to 1 n into n minus 1. When we put the value 1 here, we get 1 minus x whole to the power n upon n minus, this is going to be 0 if we put x, therefore, we do not need to put that, dx is equal to integration 0 to 1 n minus 1 into 1 minus x whole to the power n dx. Is equal to n minus 1 goes out, 1 minus x whole to the power n plus 1 upon n plus 1 from 0 to 1, but it comes with a negative sign because x here is negative, is equal to minus n minus 1 into 0 upon n plus 1 minus 1 upon n plus 1 is equal to n minus 1 upon n plus 1. Therefore, we get the same result as before. Another way of doing it is use Jacobian and compute the PDF of x n minus x 1. I leave that as an exercise. Let us now look at order statistics and exponential distribution. As I have said before, exponential lambda has a closed form for CDF, that is probability x less than equal to x is equal to 1 minus e to the power minus lambda x. Hence, we get many interesting results for exponential lambda distribution. One that we have already seen, that if x 1, x 2, x n follow exponential lambda, then x 1, the order statistic, follows exponential with n lambda. This we have already seen, so I am not going to prove it again. So, let us consider this following result. If x 1, x 2, x 3 are IID exponential lambda, what is the expected value for range is equal to x 3 minus x 1. Since expected value of range is equal to expected value of x 3 minus expected value of x 1, let us compute them separately. Now, x 1 follows exponential with 3 lambda, that we have seen. Therefore, expected value of x 1 is equal to 1 upon 3 lambda. Now, x 3, what is the PDF? It is very simple. Out of 3, we choose 1. That can be done in 3 ways, and put it at the point x, that gives us f x, and the remaining 2, they are less than equal to x. Therefore, 1 minus e to the power minus lambda x whole square is equal to 3 lambda e to the power minus lambda x into minus 2 e to the power minus lambda x plus e to the power minus 2 lambda x is equal to 3 lambda e to the power minus lambda x minus 6 lambda e to the power minus 2 lambda x plus 3 lambda e to the power minus 3 lambda x. Therefore, expected value of x 3 is equal to integration 0 to infinity x 3 lambda e to the power minus lambda x dx minus 0 to infinity x 6 lambda e to the power minus 2 lambda x dx plus integration 0 to infinity x 3 lambda e to the power minus 3 lambda x dx. So, let us calculate them one by one. Integration 0 to infinity x 3 lambda e to the power minus lambda x dx is equal to 3 into expected value of exponential lambda is equal to 3 by lambda. The second term is, so minus integration of 0 to infinity x 6 lambda e to the power minus 2 lambda x dx is equal to 3 into minus 0 to infinity x 2 lambda e to the power minus 2 lambda x dx is equal to minus 3 upon 2 lambda. And thirdly, integration 0 to infinity x 3 lambda e to the power minus 3 lambda x dx is equal to 1 upon 3 lambda, because it is the expectation of exponential distribution with 3 lambda. Therefore, expected value of range is equal to 3 by lambda minus 3 by 2 lambda plus 1 by 3 lambda minus 1 by 3 lambda coming from expected value of x 1 is equal to 3 by lambda minus 3 by 2 lambda is equal to 1 by lambda into 3 minus 3 by 2 is equal to 1 by lambda 1 plus 1 by 2. Let us now calculate the expected value of range when 4 samples are taken from exponential with lambda. Now, expectation of range is equal to expected value of 4th order statistic minus expected value of the 1st order statistic. Now, expected value of x 1 is equal to 1 upon 4 lambda, since minimum of 4 observations will follow exponential with 4 lambda. Now, expectation of x 4 is equal to what? To compute that, let us look at f 4 of x, which is going to be, out of 4 you choose 1 and put it at the point x with f x, and the remaining 3 will be in less than x. Therefore, f x to the power 3 is equal to 4 lambda e to the power minus lambda x into 1 minus 3 into 1 square into e to the power minus lambda x plus 3 into 1 into e to the power minus lambda x square minus e to the power minus lambda x whole cube is equal to 4 lambda e to the power minus lambda x into 1 minus 3 e to the power minus lambda x plus 3 e to the power minus 2 lambda x minus e to the power minus 3 lambda x. So, that is the PDF for the 4th order statistic. We can write it as is equal to 4 lambda e to the power minus lambda x minus 12 lambda e to the power minus 2 lambda x plus 12 lambda e to the power minus 3 lambda x minus 4 lambda e to the power minus 4 lambda x. Therefore, expected value of x 4 is equal to integration 0 to infinity x into 4 lambda e to the power minus lambda x dx minus 12 into 0 to infinity x lambda e to the power minus 2 lambda x dx plus 12 into 0 to infinity lambda x e to the power minus 3 lambda x dx minus integration 0 to infinity 4 lambda e to the power minus 4 lambda x into x dx is equal to 4 by lambda minus, if we take 2 inside, we get 6 upon 2 lambda plus, if we take 3 inside, we get 4 upon 3 lambda minus 1 upon 4 lambda. Therefore, expected value of range is equal to 4 by lambda minus 6 by 2 lambda plus 4 by 3 lambda minus 1 by 4 lambda minus 1 by 4 lambda. This is coming from expected value of x 1 is equal to 1 by lambda 4 minus 3 plus 4 by 3 minus half is equal to 1 by lambda into 1 plus 8 minus 3 by 6 is equal to 1 by lambda into 1 plus 5 by 6 is equal to 1 by lambda into 1 plus 1 by 2 plus 1 by 3. Therefore, expected value of range when 3 samples are taken is equal to 1 by lambda 1 plus half. Expected value of range when 4 samples are taken is equal to 1 by lambda into 1 plus half plus 1 by 3. A natural guess is expected value of range when n samples are taken will be 1 by lambda into 1 plus half plus up to 1 upon n minus 1. How to prove it? To prove this, we need some other results. So, here is a result. Show that if x 1, x 2, x n are IIDs with exponential lambda, then x r and x r plus 1 minus x r are distributed independently. That is a very interesting result. And second thing is the PDF of x r plus 1 minus x r is exponential with n minus r lambda. So, we want to show this answer. We know PDF of x r is equal to factorial n upon factorial r minus 1 into n minus r factorial f x to the power r minus 1 minus f x to the power n minus r into f x, and the joint PDF of x r and x r plus 1 is, how to get that? Suppose x r takes the value x, x r plus 1 takes the value y, then there are r minus 1 observations here and there are n minus r minus 1 observations are there and 0 observations in between. Therefore, if r comma r plus 1 at x y is equal to n c r minus 1 f x to the power r minus 1 n minus r plus 1 c 1 times f x n minus r c 1 times f y and f y minus f x whole to the power n minus r minus 1 is equal to, after simplification we will get factorial n upon factorial r minus 1 into factorial n minus r plus 1 into n minus r plus 1 factorial 1 factorial n minus r factorial into n minus r factorial upon 1 factorial n minus r minus 1 factorial multiplied by f x to the power r minus 1 small f x small f y into f y minus f x whole to the power n minus r minus 1. Since the parent density is exponential with lambda, we have f x is equal to lambda e to the power minus lambda x and capital F x, the CDF, is equal to 1 minus e to the power minus lambda x. Therefore, f r x is equal to n factorial upon r minus 1 factorial into n minus r factorial 1 minus e to the power minus lambda x to the power r minus 1 lambda e to the power minus lambda x multiplied by 1 minus e to the power minus lambda x whole to the power n minus r is equal to n factorial r minus 1 factorial n minus r factorial 1 minus e to the power minus lambda x whole to the power r minus 1 lambda e to the power minus lambda x into n minus r plus 1. So, that is the PDF of the rth order statistic. What is f r comma r plus 1, the joint density at x y? By using the formula we derived just now, in which we can cancel this, we have n factorial upon r minus 1 factorial into n minus r minus 1 factorial into 1 minus e to the power minus lambda x whole to the power r minus 1 lambda e to the power minus lambda x lambda e to the power minus lambda y into 1 minus e to the power minus lambda y whole to the power n minus r minus 1 is equal to n factorial r minus 1 factorial n minus r minus 1 factorial 1 minus e to the power minus lambda x to the power r minus 1 e to the power minus lambda x into e to the power minus lambda y into e to the power minus lambda n minus r minus 1 y multiplied by lambda square. So, that is the joint PDF of x y. We need to find the PDF of x r plus 1 minus x r. So, let us call u is equal to x r plus 1 minus x r and v is equal to x r. Therefore, x r is equal to v, x r plus 1 is equal to u plus v. Therefore, Jacobian, as we have computed many times, is equal to 1. Therefore, if u v at u v is equal to joint PDF of x r and x r plus 1 at the point x y multiplied by 1 expressed in terms of u and v is equal to n factorial upon r minus 1 factorial n minus r minus 1 factorial lambda square 1 minus e to the power minus lambda v whole to the power r minus 1 e to the power minus lambda v e to the power minus lambda u plus v e to the power minus lambda n minus r minus 1 into u plus v multiplied by 1. So, that is not needed, is equal to n factorial r minus 1 factorial into n minus r minus 1 factorial lambda square 1 minus e to the power minus lambda v whole to the power r minus 1 e to the power minus lambda v into 1 plus 2 plus n minus r minus 1 multiplied by e to the power minus lambda u into n minus r minus 1 plus 1 is equal to n factorial r minus 1 factorial n minus r minus 1 factorial lambda 1 minus e to the power minus lambda v whole to the power r minus 1 e to the power minus lambda v to the power n minus r plus 1 multiplied by e to the power minus lambda u whole to the power n minus r is equal to n factorial r minus 1 factorial n minus r factorial lambda 1 minus e to the power minus lambda v to the power r minus 1 e to the power minus lambda v to the power n minus r plus 1 into, since we have multiplied by n minus r in the denominator, we take out that n minus r, then one of the two lambdas, one we have come here and the other will come here, multiplied by e to the power minus lambda n minus r times u. Therefore, joint PDF of x r plus 1 minus x r can be factorized into two parts. The first part is PDF of x, which is the rth order statistic. Therefore, the second part is PDF of u is equal to x r plus 1 minus x r. Therefore, we establish that one x r and x r plus 1 minus x r are independent, and secondly, PDF of x r plus 1 minus x r is equal to n minus r lambda e to the power minus lambda n minus r u. Thus, x r plus 1 minus x r is distributed as n minus r lambda e to the power minus lambda n minus r u, that is exponential with n minus r lambda. Therefore, x r plus 1 minus x r is equal to 1 upon n minus r lambda. Therefore, range is equal to x n minus x 1. Hence, expected value of range is equal to expected value of x n minus x 1 is equal to expected value of x n minus expected value of x n minus 1 plus expected value of x n minus 1 minus expected value of x n minus 2, and like that if we go, we get plus expected value of x 2 minus expected value of x 1 is equal to expected value of x n minus x n minus 1 plus expected value of x n minus 1 minus x n minus 2, like that expectation of x 2 minus x 1 is equal to 1 upon lambda 1 upon n minus 1 by taking r is equal to n minus 1 plus 1 upon n minus 2 plus up to 1 is equal to 1 upon lambda 1 plus half plus 1 by third 1 by 3 up to 1 upon n minus 1. So, that is the result that we wanted to prove. Okay, friends, this is a very important result. In fact, the result can be even more generalized, that it is not only successive difference, even expectation of even the distribution of x r plus k minus x r is also independent of x r. I like you to prove that as an exercise. Okay, friend, I stop here today. From the next class, I shall start with convergence theorems for probability distributions. Okay, friends, thank you.